Hi everyone, welcome your math channel MathnaClick. I want to briefly introduce myself again to you. I'm Carlos, my mother tongue is Portuguese, I'm a math teacher and I have some important math topics to share with you. Suppose you are surrounding your yard and that you have a limited amount of material to surround it. Do you know how to get the maximum area? Let's find out. Let's go. Here we have our class team maximum area. Imagine the following situation. Just a second, sorry. We have here our problem. Mark has 1,000 feet of fence available to fence in the rectangular yard next to his house. What is the maximum enclosed area if the side along his house does not need to be fenced? First of all, let's think about a little bit about the situation, all right? A good way to think about the situation is drawing. You can think about a rectangle and you can think about this side that you don't need to fence it. All right. In this case, how can you to solve this kind of problem? Think about the situation. Let's move on to the next slide. Let's think about the situation in this way to get the maximum area, the maximum enclosed area, we using this material, 1,000 feet of fence available. All right, let's move on. Let's think about this situation. We have here the rectangle shape. We have here the width. We can name this side as X. The opposite side is the same because it's a rectangular shape. We have here X also. And we can think about the remaining material. We have the amount of material in the total 1,000 minus 2 times X. We can think about the amount of material that we had in the problem, and we can subtract minus the both sides equal X. All right, in this doing so, we get here the measures of our rectangle shape, and it's important to remember that you don't need the fence to fence this side because we have the house in the side, right? Let's move on. As we saw in the last slide, we had the rectangle shape, this side X, this side X. We called these both sides as X because they are the same, and the remaining material we calculate by subtracting 1,000 minus 2x. All right, now you need to remember how to calculate the rectangle area. Do you remember? Basically, you need to multiply the both sides, the width and the length, okay? We have here the both measures, 1,000 minus 2x times x. And to simplify this expression, it is easiest to multiply, to do this distribute here. X times 1000 and the 2x times x, we get 2x squared. All right, and how to calculate the x? How to calculate the x in order to get the maximum area? Remember that we are working with a standard, a pattern of equation. We have here an equation that its graph is a parabole right over here, and we have the minus in front of 2x squared. Soon we have a parabole in this, like this drawing, and we have the maximal point here, the vertex, and we can get the x coordinate of the vertex using this kind of formula, all right? Minus b divided by 2 times a. Remember that in a standard equation, you have a complete equation. You have a x squared plus b times x plus c equal 0. This is a standard equation, and you have b in front of x, you have a in front of x squared, all right? So you can find this information here. What's the number in front of x squared? You have 2. This is a, all right? Minus 2. And what's the number in front of x? You have 1000 minus 1000. Minus 1000 because we have minus in the formula, right? And then doing the math, you can multiply here, times 2 times 2 times minus 2, we get minus 4, and then we get the result by doing the division, and we get here doing minus 1000 divided minus 4, we get 250. It is the x coordinate of the vertex. This x coordinate give us the maximum area because he is on the top in the parabole, all right? But the problem asks us not just the x coordinate. The problem asks us to solve the maximum area. We can think about this area that we get here. We had originally, I'm going to clean here just a second. Originally we have here the area 1000 minus 2 times x minus times x. We can replace the x by the value, the number that we got in the end, right? We got as a result. We can do here the replacement. Instead of my x, we put the value that we got in the end in the x coordinate of the vertex. We can multiply here. 2 times 250, we get 500, and here we can subtract 1000 less minus 500, we get 500, and in the end we can multiply 500 times 250, and we get in the end this final value that is the measure that allow us to get the maximum area. The measure, it's the maximum area. If you use the measures based on this value, this x coordinate, you get here the width and the length 500 and 250. We find here both sides of the rectangle shape. Using these measures, we get the maximum area 125,000 square feet. All right, we get here the maximum area. It's the end of our class. I appreciate your audience. Thanks so much. See you soon. Bye bye.